Hello everyone, I'm Cole.
My name is Fatima.
We are
Me.
I know you carried out many experiments using X-ray diffraction to determine the phase and crystal structure of a sample you control.
Yes, Professor.
During your experiment, any chance to take a look at inside? There must be small, the transparent objects.
Yes, it was a tiny glass, but it was not so clear.
But you must know the function of these two.
Yes, I heard it would generate X-ray.
The class is talking about generation X-ray as a new chapter that is divided into three different pieces. X-ray tube and two different types of X-ray, continuous, characteristic X-rays. As the first minor chapters, I want to describe X-ray tube, and then for your easy understanding informations, I will show you the schematic illustration of X-ray tube briefly.
This would be useful, Professor, since we never see directly the instrument inside the X-ray.
Right? This is the minus, and then this is positive. And the one containers made of glass, we can call this
Glass tube?
glass tube. And then, can you guess what is inside the glass tube?
Sure, Professor. The glass tube condition should be vacuum.
Before that, must be cathode and anode.
Oh yes, of course. Inside should be many elements.
The vacuum. Yeah, you're right.
Yes.
So why we use vacuum?
The vacuum is necessary, Professor, because we use the filaments inside, and then we should protect all that kind of instrument inside, because as we might know, when the voltage is applied, we can expect high temperature will be generated, and in normal condition, it would generate issue such as high temperature corrosion.
Right. It's very good point. In addition to that kind of phenomena, one more issue. Once X-ray will be generated from this tube, and then if the air inside, X-ray just kind of light will be absorbed or scattered by the air. That's why we have to make it a vacuum.
Understood, Professor.
Left side, this should be
Cathode.
cathode. The right side,
Anode.
anode. In anode, this tiny material will be metal target.
Is it made of copper, sir?
Copper, sometimes chrome and cobalt, but copper is generally used.
General one, copper.
And you pointed out before, and then high temperature, high voltage will be the issue. So these parts made of copper rods for heat dissipation.
Heat dissipation,
Right.
copper.
And then we can find the small window here. Okay, this is a general schematic illustration of X-ray tube itself.
Professor,
Yes.
I have one question.
Yes.
Is it intentional that Professor draw the surface of anode a little bit inclined?
That's a very good point.
Any
You mean
reason?
this part, right?
Yes, Professor.
Yes. Before doing this, and then what is this one?
Filament,
Made of tungsten.
tungsten.
Tungsten filaments. And tungsten filaments can generate a number of electrons
Yes.
by thermal ionic emission.
Thermal ionic emission.
Right. So some electrons moving out from the tungsten filaments. Surely this is the minus and migrate toward the positive to anodes. Anode. After interaction with the metal target, it can generate X-ray here. If this part is very parallel to the cathode, we cannot take any kind of X-ray. You understand that?
Yes, Professor.
That's why this part should be inclined a little bit.
Okay, thank you, Professor.
From this circuit, and then we just give some kind of high voltage here. So energy should be electronic charge and then voltage. It's just kind of potential energy. And this should be same as the kinetic energy.
Kinetic energy.
M
mv
square. There are two V. This V should be voltage. Small v means velocity. So let me summarize. E will be electron charge and
charge.
Can you remember the value?
It's about 1.6.
1.60 10 to minus 19. C is coulomb. And then voltage. Acceleration voltage, okay, let's say we just give 30,000 voltage.
Wow, so high.
Very high, but it's not so high for the X-ray tube. So this voltage. Next value is M.
Should be mass.
Electron mass. Can you remember? 9.11 10 to minus 31 kilogram. The last one is
V.
the velocity
of the
electron. Velocity of electron before impact to metal substrate. metal target and then before impact. So I really want to know the velocity here.
So
interchange V. This means
equal to
2 EV over M. So that's why V
equal to square root of 2EV over M.
Yes. This is our final equation today. Very simple. And then we can put all this variable into this equation. Here, the V, small v, and then roots, the many variable, and then 2, first of all, electron charge 1.60
times 10 to the power of 19
minus 19, and we can see
coulomb.
And then the voltage here, let's say and assuming, and then 30,000 volt. Volt to change into joule
per coulomb.
Right? Everything is good. And the M value will be 9.11 and 10 to
the power of minus 31.
And then kilogram. 자, C out. And then joule per kilogram. But the joule will be kilogram
per
meter square
per second square.
Right?
Yes, Professor.
So that's why this kilogram is out.
Yes. And then because
roughly you can calculate 2, 1.6, 3.2. 3 times. Approximately 9.6, right?
9 over 9.
9.6 over 9.11.
11
Yeah, surely it must be the roots.
square root
10 to minus
power
19. 1, 2, 3, 4. Right? Plus 4 plus 31.
31
And the units should be meter square per
second square.
second square. Let's say this value 1.
1%.
And from this value 35 minus 19. That should be 16.
16
Right? So the final value 10 to 8 meter
per
per
second.
second. Oh, can you remember the velocity of the light?
Yes,
Oh.
around 10 to the power of 8, sir.
C light should be 3.0
0 oh,
10 to 8
meter
meter
per second.
So very incredible numbers. 자, voltage 30,000 and then velocity of electron 10 to 8 is 1/3 of
The light.
the
velocity.
speed of the light. And then
Wow.
but I want to give one question.
Yes,
and then 자, look at that. This is the final equation. Right? Here this voltage
Voltage.
increase and then velocity
Increase.
increase.
Yes.
Right? Not decrease, increase.
Would be increased because
Increase.
parallel.
Yeah, proportional.
Proportional.
So if we just increase voltage and this velocity even over the speed of the light,
Oh, that is interesting question, Professor.
right? It's very interesting.
Yeah.
Is it possible or impossible? From this equation, it's possible.
From the
High
equation.
voltage can generate high velocity.
Yes, from the equation I think possible, but as far as I heard, the light is the fastest. Professor.
Right. So I will show you the reason why this velocity should be lower than the speed of the light.
Wow, it will be interesting.
And then 자, voltage increase and then 자, velocity of the electron velocity can exceed that of the light. And
The
then
speed of the light? As far as I heard, Professor, the light has the highest speed.
right, that's
But
true.
I'm sure that the formula we talked about before is also correct. Now I'm confused. Which one is right?
Yeah, it's very confusing,
Yeah.
right?
Can you explain?
Okay, sure. And then the answer is impossible.
Possible.
Based upon the relative theories suggested by Einstein more than 100 years ago, and then mass will formulate like this: 1 minus square and then c square. C means
Speed of the light.
speed of light, and approximately c should be 300,000
300,000 kilometers
kilometer per
per
second.
second.
Okay. What about do you know the world record of any kind of transportation?
I know some transportation has high speed like KTX, Professor.
KTX, just one of them. But what about the airplane?
Airplane. I'm not sure, but
800 kilometer per hour.
800 kilometers, but per hour.
Per hour. It's not a second. That's what is not useful. What about that spaceship?
Spaceship. I guess it would be faster, Professor.
Much faster than the airplane.
Yes, but I'm not sure about the value.
Spaceship. its velocity is approximately 10 kilometer per second.
Oh, per second. Much faster.
Much faster. One satellite or one rocket will be escaped from the Earth, and then the minimum speed should be 11 kilometer per second. So anyway, I want to give this 10 kilometer per second for easy
For
calculation.
easy calculation.
So m0
M0 over square root of 1 minus
자, 10
10 over 300,000.
100,000 and then square.
Yes, square.
0 out.
Yes,
1 over this high value,
high value.
and then
Very small number.
small number, we can ignore this value. So that's why
Negligible.
final the result m is m0. The mass remain constant. Second. 자, velocity very close to the speed of velocity of the light. We can give 0.9 c. What happened?
0.9 c
m
equal to
m0
0
over
square root of 1
Square.
minus
자,
0.9
square. This value 81.
Yes.
So approximate calculation, this value should be 2.3
2.3 m.
m0.
Ah, the increase.
Increase. So although speed of electron will increase significantly, it's impossible to exceed the speed of velocity of light because
Because
its mass will increase
also increase.
gigantically. That's what is very impossible.
Understood, Professor.
What about
Wow,
that?
interesting.
Velocity will be 2c.
If become 2c,
2c.
let's we input in the
M
equation
m0
m0 over square root of 1 minus 4.
This value is
Negative.
negative. That's why we cannot achieve this kind of
Yes.
value. So it's impossible from the equation suggested by Einstein.
Understood, Professor.
This was additional part, and then so today I want to talk about the X-ray tube and for the generation of X-ray. And in next class I want to talk about two different types of X-ray, continuous and characteristic X-ray. So the moments we can see you later.
See you again.
See you.